Hello, everybody. Mr. Rubo here. We are looking at topic 1.12 today, transformations of functions. This is something you've done in previous courses. You'll also use it in this course. You'll also look at it at future math courses you take. Um, it's a great way of connecting the equation to the graph and parent functions and all of that. So let's go ahead and look at this table. So this table gives us four of our big transformations. There are more, but for right now, we are looking at just these four. Um, so in all of these cases, f is our parent function, our normal function, g is the transformed one. So if you ever see, and you'll kind of notice, oh, f has been moved to g by going up or down, in this case 2, whenever that happens, when it's an up or down movement, it's f of x plus k is how we write g of x. And that means that f has had a vertical translation or movement or shift of k units. So whatever that number is. So again, like in this one, f is up here, g is down 2 units the whole way. What we would write for g of x is f of x equation minus 2. And just put a minus 2 at the end. Okay, and that tells us we've shifted f of x down 2. All right, now g of x in the next one, if we look, f is the solid one, g is the dashed one. It has been moved to the left. So the way this one looks is you write f of x plus h, but the x plus h part is inside parentheses. Okay, it has to be grouped together. That's going to tell us our horizontal translation. Okay, has a horizontal translation of negative h units. It's also the opposite of what we think. So normally on a number line, you think, oh, to the right is positive. Here, if you see something moving to the and left is negative, if you see something moving to the left, you're actually going to write x minus, and this was 2 units. Minus for right. This one moved to the left, so it's plus 2. Okay. Okay, so if this had been moved to the right, you would have had the minus. If it's moved to the left, it's the plus. Okay, so there's your two addition ones where you either add it outside the function or inside with x. Now we have multiplication. So you could multiply the outside of the function. This is what we call a vertical dilation. Okay, you might have called it a stretch or compression. That's a little bit more confusing because it's two different terms for the same transformation, right? Stretching means, oh, you're getting bigger. Compressing means smaller. Dilation just means it's changing size. Much easier. And in this case, it is by, we're going to put the absolute value by a factor of the absolute value of a. Okay, so this one, it has a flip, which we'll talk about that in a second. But it is also normally would be at 2. Now we're at negative 4. This point was at 2, and this point is a negative 1. It's now at 2. This point was at 1. Now it's at negative 2. So if you notice, they've all doubled. So we have 2f of x. But if we also have this flip, which we would call reflection, and it's a reflection over the x-axis, so we have to make it negative. Okay, that's again, whenever you have a reflection over the x-axis, you have to put a negative out in front. All right, the last one is when we have the multiplication on the inside. Okay, and actually I'm going to change letters here because I don't want it to be confused. We're going to call it B. So this one has a horizontal dilation by a factor. Now this is where it gets a little confusing. The absolute value of 1 over b. So it's a reciprocal of b. So here, if we look, f, this one It's an interesting graph. So if you notice, it's actually the same size. So our b value is actually 1, but it's been reflected. Okay, so because of that, what we're going to write is f of negative x. Okay, and here our b value is less than 0, and that means it's been reflected over the y-axis. Okay. All right, so a few important tips. Any transformation that affects the x values will occur inside the parentheses with the x variable. Inside parentheses could also mean inside a square root, inside, like it's grouped with the x. Okay. Any transformations that affect the y values will do, I'm sorry, with the x values, because we're still talking about x's, will do the opposite of what it looks like to the x values. So we saw adding made it go to the left, subtracting made it go to the right, multiplying, it was the reciprocal. Okay, so it's like we're dividing. Any transformations that affect the y will occur outside the parentheses, and the y values will do exactly what it looks like to the y values. So you add, you're adding, subtracting, multiplying, you're multiplying, not worrying about dividing or doing any sort of reciprocal. Okay. All right. Well, thanks for watching and have a good day.